Okay, so as a continuation to my last tutorial, let me just repeat the exercise again. So as you can see, the whole port here, the output are all disabled. Only the inputs are enabled. So this is telling you that at the reset, let me reset it so you see. So at the reset, the port acts as an input, because the port duration are all zeros, so they all act as an input. But remember, I told you in real life you won't have the ports again here. You only have them at one place, but they'll be serving the same purpose as an input and an output, just like your Arduino pins can serve both as an input and an output. So but for logic sim, actually there's need to separate them. So but this shows you that it's not functioning as an output, rather here is functioning as an input, the ports. So these are the outs and the ins of the port. So let's do an exercise. So let me write this particular bit 1101 as an in. Then I'm going to read this bit 1010 as an output. So sorry for my writing. So first thing I'm going to do, since I want to I want this 1010 to show as an output, so I'm going to put it here. So as in the total bit is going to be 1101 1010. So but the 1010 is coming as an output, while the 1101 is coming as an input. So this 1010 that is going to show as an output, let me set it here first. 1010, because I'm trying to use here as an output, while let's go to the port. I'm going to use here as an output, and then here as an input. So this place will be disabled and this place will be disabled, but it's looking confusing because the ports are actually separated. So at the end of the day, you have here and here joined together to make a full 8-bit. So but for this particular session, I'll be inputting this data here, and for this particular session I'll be reading this data out. So the one that I'm reading, which is the 1010, I've already set it as an input here. So okay, sorry, first thing I have to do is I have to go to the data duration register first and set this particular place as an output, which is 1. So to do that, I'm going to set the 4 of them as 1. Then remember, the data register, the port data duration register of port A is 1. So I've set the address, I've set the data in. So the next, I make a reset so that everything is starting afresh. So I'm going to set the chip select to select the IOPORT chip. Then I'm going to turn it on as a read, this is going to be off as a write mode. So at this point, you can see that these zeros as common. These zeros have common. It means that I've set the last 4 bits as an output, but I didn't put any value there. It's still 000. So I'm going to input this value there now. So watch how I do that. So I turn off this chip select, then I put the data I want there, 1010. Then I select the data register of port A, which is 0. Then what I just did earlier was to set the port direction. Now I'm now sending the data 1010 there. So watch how it's going. What do you see? You can see the 1010 has appeared there as an output. Then I want to set this as an input. So already the last 4 bits of the port A data duration register is still 00, so it's already an input. So unless I'm trying to set it an output, that's when I will go back there and change the values there. So I'm now going to simply write 1 since it's already an input 1. So what do you see here? This is it here. 1101 as an input, then 1010 as an output. And you can see here that the 1010 comes to the output, and in as much as I have 000 at the last 4 bits, it doesn't affect what is coming out here. It insists on the 1010 because it's serving as an input and not as an output. So I hope this is a bit more clear now. So you can likewise change individual bits. Thank you. Please subscribe to my channel.